You're tuned into our webinar, Achieving Maturity in Maritime AI by Differentiating Neuro and Classical AI. Today's discussion will be led by Carl Jeffries, CEO of People Tech Maritime, and Dimitri Liras, Managing Director of Ulysses Systems. If you have any questions, do leave them in the Q&A section for answering later. Over to you, Carl, to start the talk.
Okay, so we're going to talk today about how we might be on a better path to achieving maturity in maritime AI if we differentiate neural network AI, such as large language models, with other forms of AI. So the idea for the webinar came out of discussions at our People Tech Maritime events in Athens, Bergen, and Oslo over the past 5 months, where people often talk about AI as though it's one single technology, which you're simultaneously excited about, astonished by, confused by, and threatened by. And a common message is that we don't have much idea of what to do with it yet, and we need to experiment, and people presented some things that work. So an idea we're sharing today is that maybe the maritime industry can do better than this if we look at AI as separate technologies. So we're calling that neuro AI versus traditional or classical AI. So neuro AI is used in large language models, is completely different in its capabilities and costs, implementation challenges, and strategic approach needed from other forms of AI or other forms of software. And when we talk about other forms of AI, we get into a knot because some people define AI as anything a computer does, which was previously done with a person and their intelligence. So in this definition, it would include a ship, which is simple to program, or other people define AI as something involving machine learning, where the machine learns how to do something better, such as getting a better relationship between the speed and power of a ship. So the point I want to get across here is that not all software is neuro AI, and not all AI is neuro AI. If you think about the Iron Dome missile defense system that sends up interceptor missiles, it's very sophisticated software, but it's based on physics, and there's no AI in it. And if you think of the sophisticated market simulation and modeling tools used by chartering managers for matching ship cargoes, or think of voyage optimization tools we have for understanding the relationship between power and speed of a ship engine, creating models to see what our emissions and CII score are likely to be for the year, these software tools don't have any large language models or any form of neuro AI in them. So anything other than neuro AI is technology we're much more familiar and comfortable with because we've been using it for decades. So if we look at neuro AI more closely, the capabilities are always changing, and it's dangerous to say what it can't do, but there's things you can say for sure it can't do because it's got no way of doing it. And that's understanding everything you know as an operations person in a shipping company and everything your current operations software knows. So you must be working with enormous amounts of information in your mind together with the data in whatever software systems you use, and you use it together with incoming information to get situation awareness and make decisions. You might be working in chartering or procurement or safety management, working on board vessels or anywhere else in shipping. Whatever your role is, you've got specific goals you need to achieve. They might be related to money, safety, reliability, speed of doing tasks or emissions or anything else. And you do this by getting situation awareness of what's going on. You do this based on what you see from talking to your colleagues, from your email, from your software systems, and you combine it with what you already know. So as an expert, you've got a complex model in your mind about how the part of the operation you're responsible for works. And the LLM is never going to have the level of knowledge as you and your traditional software do. And there's nothing in an LLM software which enables it to store data about what's happening permanently. For example, if you wanted to set an alert if certain conditions happen in future, something we might do with almost any traditional software, it can't be done with an LLM. So someone could take a counter argument here and say an LLM may be able to do all this one day if it can read the same data in emails and talk to people and build its own permanent models of your situation just like you can. Well, that's possible, but it's certainly not where we are today. We need to have all the information in a digital form so a computer can work with it. And remember, lots of the information in your head came from what you were told or saw, and it was never in digital form. We need to have some means of converting the complex data in our software systems into something the large language model can understand. And once we've done all of that, we might find that the ability of the LLM to understand a complex situation with multiple factors and assess the risks is nowhere near that of a human. But you can also remember that traditional software can be programmed to do all of this, storing the information you need and supporting your decisions. For example, if your goal is smooth coordination of all the activities which happen in a port, such as arranging surveyors, taking out deliveries, sorting out inspections, there's software which will help you coordinate this. If your goal as a chartering manager is to get the best cargoes for your vessels based on vessel locations and what's in the market and make future predictions, there's software to help you do this. If your goal as a vessel performance manager is to make sure the vessel hits its emissions targets and customer promises for the year based on where you are now and advising on what you need to change, there's software to help you do that. So those are just a few examples of great traditional software out there which has got no large language models in it. Making software to do this needs to be done with people with a lot of maritime expertise, so it's not cheap. But if it helps you in your goal of getting the ship out of the port on time or finding profitable cargoes, then it's well worth paying for. So what can large language models do in shipping? Well, what we've seen so far is their biggest strength is anything relating to creating language and computer code. Many people use them to help write emails, translate text and write reports, or work with complex procedures and company manuals and create training materials. And one of the biggest uses of LLMs, which is emerging now, is when we use it together with traditional software. So instead of working with the complex user interface of the traditional software, we have a chat-based interface to the LLM. The LLM is able to talk to the traditional software. That's very useful if you don't know the software so well. LLMs are being used to convert data from one format to another. That will help us get around the problem of not having standardized data, so we can share and put together data more easily. So I think the heavy lifting of maritime digital technology will continue to be done by the software applications we have today, which are designed to support you in your goals, and we'll use neuro AI at the edges to augment and connect this together. There's another example we've seen is when navigators have their traditional situation awareness from chart systems and radar augmented by image analytics tools, which analyze video images of the ships around them. So our future digital architecture is probably going to involve a mix of neuro and traditional AI components, all doing something useful. And as buyers or IT managers, we can easily see what they're all doing and whether we're getting a return on our digital spending. So that would be AI maturity. But to do that, we've got to separate neuro AI and other forms of AI and software in our planning and get a clearer picture of where we're going with this and how to put the tools together. So that's the way to get good management of procurement, chartering, navigation, safety, emissions, maintenance of whatever our role is. And there's a last point I want to make. It is in the interest of the big tech companies that you do see AI as one single technology, because it then follows that you can only buy that technology from them because they're the only people who provide it. You get dependent on them. They get a bigger piece of your cake. And it makes a lot of sense for you as a shipping company person to oppose that and build your own understanding of the various technologies and what value they specifically bring. So I'm now going to pass on to my co-speaker, Dimitri Liras. Dimitri is director of a family shipping company, Paralos Maritime. He also founded a maritime software company called Ulysses Systems. They make software to improve coordination of activities, which I described earlier. Dimitri and I have written 12 short books about how to better design software systems to support domain experts in meeting organizational goals. You can find them on Amazon if you search for software for domain experts. So Dimitri is going to explain more what a mature AI landscape in maritime looks like. So I'll pass over to Dimitri. Cheers.
Thanks very much, Carl. Thanks for having me here. I don't know much more than any of you about neuro AI because we are experimenting with it and using it where it works for us and looking into what it does and what it doesn't do and try and understand what can be done in the future. So you're not going to hear anything particularly new here, but you are going to hear something that has to do with really focusing on making software more usable and really focusing on making software achieve common sense. Now, what is common sense is a good question, and we often argue about that, and the field of software engineering hasn't really embraced it very much. I will just say that common sense is when you talk to somebody and you find that they understand you, you understand them, and the terms you're using are familiar to both, and the subject that you're addressing seems to be addressed well by both of you. That's a sign of common sense. I can give you a lot of other signs of common sense. There is an argument that common sense is knowing how the world works to know gravity and be able to define how it works and so on. But I don't believe that's totally true. I think that the common sense is the common sense that you use. It's the information in the world you use to get things done. Coming from that background of common sense, I can give you a short, let's say, a view of what neuro AI does and what conventional symbolic AI, which it's called symbolic AI now to differentiate it. You didn't need that word before, but now you do. So neuro AI actually takes what you read, as you probably know, it takes what you write and what people have written before and synthesizes it. It's got a very, very clever way of making patterns out of anything that has been said in the past and that it's been trained on. So, and it picks up your prompts and synthesizes them and matches them in a vector signature, let's say, with the closest thing you can find on the internet. This is fantastic technology. Um, and it's the reason why it also hallucinates, as you probably know, is because it always comes up with an answer, whether that answer is based on fact or not. And it has no way of knowing whether the information is picked up is fact or not quite fact. So it's a fantastic tool, and it has unbelievable applications. Um, but it differs from what we thought intelligence was, because we thought intelligence was people reasoning. This system doesn't reason. It takes the reasoning of other people and it synthesizes it and it produces it when it thinks that it matches your prompt. So that world is completely different from the symbolic world, which Carl was alluding to, which is systems that actually do the reasoning with formulas and models and facts and so on. So a symbolic AI is what you have in your enterprise right now. If you have an accounting system, it's a symbolic system. You may think it's AI, and but it can reason and do clever things, and when it does clever things, then it's AI. Definition of AI I heard some years ago was that AI is what you think is clever, and after you've figured out how it works, you don't think it's clever anymore, and you don't think it's AI. So normal computing does produce things like the Iron Dome, which Carl alluded to, and that is complex physics and complex calculations, and that produces a result that people rely on to stay alive there. So when you mix that, let's go back to combining the two now. If you combine neuro AI with symbolic AI, what you're doing is you're taking the reasoning and the facts and the persistence meaning that the software remembers what you told it, and it turns it into a result. And the neuro part is the part that can take what you're saying and go out on the internet and give you an opinion about what else is going on around that problem. It can also study images, it can study situations and give you a vectorized result from the information you're giving it. Now, what doesn't work very well is the two don't go together, they don't mix immediately. As Carl also alluded to, the world of AI is, as you have experienced, very driven towards convincing you that they're going to solve everything. And that's understandable. They have to sell these things. So they will tell you that you can put all your information inside a large language model, and that information will be interpreted by the large language model, and it will be turned and it will enhance the factual and instantiation parts of your combined system. No, it won't deal with the instantiation. If you put your stuff in an LLM for it, or your file server content into an LLM, it's not going to instantiate anything. You can't then tell it, well, this purchase order came in, so I've seen it, and that goes and pushes the workflow onto the next stage. It won't do that. It will take in all the information you give it, and it will do some sort of interpretation of what you gave it. But remember that software today isn't built for to think, and it's not built to reason on its own. It's built for you to see what it has and for you to reason. So if you see a UI with the purchase order you want on it, and with the delivery dates you want and the port you want and so on it, you are combining those things. The software itself isn't reasoning. It's not doing that. It's not that it can't. It's that people use software in their enterprises to inform them and coordinate them. They don't have self-aware software. So in order for the system to communicate with you, it would be nice if it had some sort of self-awareness. We believe that the future, the immediate low-hanging fruit in using LLMs and conventional software, is where you use the LLM to talk to the software, to write, to ask questions. What happened to this purchase order? Is it going to get there on time? To do that, you need to mix the existing ERP system which you have with something that the question from the LLM will match. And for that to happen, you need the question to be as it is. Will this stuff get there on time, and will it be ahead of the vetting inspection that we're about to have? And the system then has to go and find in its current storage of information what the latest status is and how to answer that question. That's doable. It's not easy, but it's doable. We believe that that's a good target for systems, because many people that need to use systems now experience, anybody that's of some seniority and above is no longer familiar with the system. So they can't answer questions, they can't ask questions, they won't get answers to the questions, let's put it that way, by navigating, because it's just too many systems to navigate and too difficult to get your head around everything. I think an analogy here is why you need a user interface with text is because the ERP system that you have has been set up in the way that it's been set up, just like your file servers are set up the way you set them up. The information is here or there or somewhere else. And it's very difficult for your ERP system or your file servers to actually explain to some entity, some intermediate layer, what those things do. What does a PDF file coming from a vendor do? What does it do? It tells you about their standard terms, tells you about what. So, or what does the actual form that you receive from a ship from, let's say a tank entry form, what does it do? What is it used for? What does it achieve? So in order for the system to answer questions like, will this thing get to the ship and be ahead of the vetting inspector, that will need to know that the vetting inspections involve defects, and defects involve purchase orders, and purchase orders involve getting things to the ship, and the getting things to the ship has to happen before the next inspection happens, and so on. So in order for a conventional system to be able to communicate by verbally or by text with something, it has to be organized in a common sense way, which means that things are connected by cause and effect. You will find that in your software today, there is no connection of cause and effect between your purchase order and your vetting inspection. There may be a database connection there, but that doesn't tell you that this thing, when this happens, that happens. It doesn't do that. So you have to build a layer to merge the two so that your system can be understood by the, let's say, the prompts in the LLM have to mesh with this way that your system works. And that needs an extra layer. They call these things semantic layers today. Now, something that's coming from Silicon Valley is that they are saying that this LLM can absorb more of your information, and it can start to create these correlations which the semantic layer would do, which you have to do. And then when that happens, then the system will understand what's going on in your enterprise because your file servers and so on will have connections, say it's telling the system what everything does in there, what it's for, what you need it for. That's a struggle, but it's still not going to absorb instances. Instances are where you tell it that, okay, I read that this purchase order has left the vendors, so I'm going to tell the system that this item left the vendors. That you cannot do in a system that's run by an LLM alone, that you put your data in an LLM and the LLM did figure out what everything's about and the LLM can answer questions, but it cannot be instantiated. In other words, you can't tell the system that this happened now, so the next step is that. So, I'm sorry if I'm confusing you because I'm not really trying to tell you something except to invite questions. So I hope this was enough to get you to ask some questions. Thanks very much for listening to me.
Well, very good. So we're in for questions. You should see a Q&A box in the bottom. I thought to get things going, perhaps we could talk about how neuro AI and conventional software works together in different domains that people know well. I started thinking about an autonomous car. So if you've got an autonomous car, perhaps the LLM is doing the image classification. It might be doing something to choose the routing if it's doing that. But then everything beyond that, I think, is probably physics. It's mapping the objects around it. It's working out where they're going. So that's all conventional software. So very little in an autonomous car is actually generative AI, I think. I mean, the companies don't say a lot about how the stuff works, but we can also build a similar picture for any domain. I mean, maybe not the ones you're working with directly, Dimitri, but others like crew management or ship navigation. I don't know if you think of some examples about how where generative AI can work together with conventional software. So,
Well, I think it does. The autonomous car is a good example, although certainly not part of that development. But autonomous cars, we expected autonomous cars to work with conventional symbolic AI. We didn't expect them to have to be going around in circles in Los Angeles and picking up every experience that they have and basically coming up with a decision on everything that was happening on the road. I think the two can be combined, but I think that you still need to know where you are. That's conventional AI, the GPS. You still need to know what will come after a certain action by the user, by the driver. You still need to know what will happen, where the trajectories of the other cars are going to go. That's physics and mathematics. So a lot of that. And as you know, we have that in other autopilots and navigation systems on ships. They worked that out and long before neuro AI came up. The neuro part can take in information about the situation at hand and presumably make conclusions about the image much better than any conventional could. So you would probably get a feed into the conventional system from the neural system in order to enhance its view on something. Same with the stuff that I'm involved with. If you get a purchase order, and it comes in, and the system tells you that this is the purchase order has just come in. It can tell you then the conventional system can tell you what's the next step, and the neuro system can tell you something that is more nuanced, which is what exactly did the email say, and if there's any mention there of any doubt of whether you're going to get this thing on time. So, which this conventional system wouldn't pick up. When we say that it's going to read what you say, it's going to read what you say a lot better than any other, let's say, symbolic system would have done. So the neuro picks up information from images and patterns much better. And if that information is relevant to what you're trying to do, then it should be there. I wouldn't want a system to make assumptions about when something's going to be delivered if it couldn't actually read and interpret the actual message. And if it was just a matter of that it picked up something and then it said, okay, so you've got your delivery note here. Well, what does a delivery note say? I need a neuro system to tell me what exactly it says.
Oh, very good. So we've got a question from Gorgios Mantzouris, former commander of the Hellenic Navy in Athens. Can you ask Mr. Liras to explain more about the cause and effect modeling procedure and why other AI cannot support that efficiently up to now? I think conventional AI can support cause and effect modeling. It's the neuro AI that can't support cause and effect modeling, isn't it? I think that's.
Yeah, cause and effect modeling is can be picked up. If it's been described on the internet, it can be picked up. The question, the biggest problem you have immediately is whose cause and effect modeling are you talking about? Are you talking about something you read on the internet about cause and effect? What will happen if my purchase order is late? Let's ask the internet. We will get an answer. The question is, it's not going to, the issue is that it's not going to tell us what our situation was before. Before we ask that question, this thing or whatever was being delivered was somewhere. How's the neuro AI going to know that? You've got to persist that somewhere. And that's a conventional symbolic AI system that takes in the what happened before and has a cause and effect sensitivity and can pick up what's coming up next. And so if a neuro system is asked, in my opinion, the neuro system should go and read the messages that came along, because it might not be as straightforward as you think, that it's arrived and it's going there and everything be hunky-dory. So the combination of the two is great. To have just the neuro means that you're not persisting any of the facts that apply to you in the system. That's not ideal.
Yeah. I was talking to a friend of mine in the pub last night who works in technology, but not in shipping. And in his view, anytime you hear about AI, it's always generative. And I was trying to explain why that's not true, but there's probably a lot of people in the tech world who believe that because we hear so much about this generative stuff. I don't know how, I guess if you actually work with autonomous cars, you must spend a lot of time using conventional technologies. But I suppose a lot of people in the tech world, their brain space is so full of large language models these days that it's almost getting hard to think about anything else, isn't it? I don't know if that's something you've
Well,
seen.
we have to spend, we're spending sort of 20 to 30% more time thinking about our work in the sphere of software engineering than we did before because of this neuro. So if it's not his job to work out how this all fits together, they're going to be confused, there's no doubt. We had this the confusion is super widespread. I mean, we're hearing companies saying that they have to have a policy or a strategy for neuro AI, and it's like saying 25 years ago that you needed a strategy for the internet. Let's see what you need. Let's look at what people are doing with the internet and see how we can progress. At the time, I think companies, some of them used the cleverer things. Mostly they used emails, and mostly they browsed the internet and surfed. In those days, it was surfing, and it was all very exciting. And we were being told by Silicon Valley and all the big influencers that it's going to change our world and nothing's going to be the same again. I had people, my own sort of relatives, telling me, if you don't, you have to have a portal or you have to have a B2B business. You have to run. Not in, I don't need B2B for a charter that's where the numbers are so large. I could hire three people just to look at to make sure we get the hire in or the freight. So there was a lot of bullying, I would say, from technology influencers that tell you that you have to pay attention. So it gets very confusing.
Well, we could think of, two other domains we could talk about. One is ship navigation, one is ship chartering. But both of those, there's a lot of conventional software, but there's potential for large language models or generative AI to help. So in ship navigation, we've seen these tools coming in that do, when you've got a CCTV camera looking forward, that can see ships and classify them and tell you what you're on a collision path towards. So that's using generative AI to understand the image, but then it's using traditional software to work out where the ships are moving, and then perhaps you could have a large language model that would tell you things you don't know about the situation, something like that. That's maybe a example to think about if it's a future ship
Well, it's
navigation.
it's quite mature technology, I would say. There's a few vendors out there doing good job of, and nothing could be better as an example than to have a neuro AI system looking at the screen you're looking at and picking up things that you might not pick up. Uh, that's an excellent use of the system. Um, I use an LLM every day, and I use it to understand things and tabulate things that would take me ages to find out. I was reading about a neuro AI yesterday. I read an article about why it's going to have a problem with why neuro AI systems you can't just load your ERP data and your file data in there. It didn't make any sense to me. It was written in a way that was used terms and that I don't understand, and I put it in an LLM, came out very nicely. It's that's so this is so the synthesization, or I don't know if there's a word like that, but synthesizing information is something that is fantastically well done by neuro AI. And I wouldn't be using the technology every day as a technologist if I didn't think that it has fantastic applications, including and one of them being that it puts together text in a way that you can understand it, and it doesn't have to be totally accurate. Everybody says, "Oh, but you got this out of Copilot, so you can't possibly be right." Well, it doesn't have to be perfectly right. It has to get me far enough so I can ask the right question. And so, are these tools useful? They're fantastically useful. The same as as I mentioned before, if I get an email from a vendor about some delivery thing coming out of a warehouse and where is it going to go? Is it going to be on time and so on? It would be very useful if it could read it for me, and then I have a much better idea of what's going on than if I have to sit there and read somebody's English, which is not a first language, in order to understand what they're saying. I might miss it as well.
Yeah. Ship navigation is probably quite a good analogy for many other domains as well, because you've got to have rock solid information about the chart, where the ships are, what's around you. But perhaps the LLM can augment that by telling you things that you can't see, or this is something you really want to watch out for. Of all the 10 ships, this is the one that you may be about to hit, or that's perhaps a good example. I was thinking perhaps if you look at chartering software, so you've got to have rock solid information about these are my ships, these are the cargoes in the market, but then the LLM can say, well, I thought of this, or if you take the ship over here, perhaps you won't get a return cargo. So this is an example of how people may use LLMs on top of traditional software in the future, isn't it?
Yes, I'm not, the use cases are millions, so not neither, we're not ready to answer questions about every use case by any means, but a lot of the things in chartering and operations are very hard to include in a conventional system. in operations, you have risks of cargo damage, damage to the ship, legal issues where the ship is where the cargo is discharged. You're responsible for the discharge of the cargo, way beyond the ship's limits. So all these things have connotations and effects that the LLM does know. So you can ask it, and it can remind you. It can actually help you build models of your world. It really does. Whether it doesn't persist them, and it doesn't have the technology to do that, but it does tell you enough to remind you. Let's get something straight. As a chat companion, it's a brilliant tool. If you say that it's going to actually make a difference to your collective information in your enterprise, that's not going to happen very soon. It's going to be very, very hard to get it to make a change in your enterprise that coordinates things in a different way. You can do that. You can take the information from the chat and start making changes in your ERP system. That's fine. But if you want the chat to make changes to your ERP system, you have to go about it in the right way. So that's I don't know if that's helpful to anybody.
Yeah, well, I mean, perhaps that's the time to finish. I mean, like, the story we've been trying to get across is that neuro AI is very different to conventional AI and conventional software. As a shipping person, it's your responsibility to understand these things because you can't rely on Silicon Valley to explain it to you because they probably want to give you this big story that everything's neuro AI these days. I think that's the yeah, that's a question to probably leave you with and have some discussion in the future. I don't know if you have any closing words, Dimitri, you want to share?
I think that the only closing words is we need to talk about this more because we find out things every day. So the more we discuss it and get ideas from people, the more we're going to make a good use of this new technology. It is very, very useful technology.
Oh, very good. Well, we'll finish there then. Well, thank you very much. And I shall pass back to Farah for the closing words. Cheers.
Thank you to Dimitri, Carl, and our audience members. We'll be uploading a recording of today's webinar on our YouTube channel, and we'll be sending you details soon. Join us next month on the 28th of May for our webinar with Opsilog. You can register for this on our website. See you soon.
Oh,
Thank
cheers.
you.
Bye-bye.
Thank you very much. Bye bye.